Our next session here will be how to make delicious chicken wings with Lambda functions with Bryson Tyrell. So if Bryson, if you're ready, we're happy to get started and see your session.
Thanks. Can you hear me okay?
Yep, you're all good to go.
Fantastic. Hey everyone, it's been a hot minute, but good to be back. I'm Bryson Tyrell. I'm a staff systems development engineer here at Jamf Software on the cloud platform team. And my area of specialty here is really serverless development on AWS. That's what my team and the teams I assist work with, and that's what we're going to be talking about here today. And in a long-standing tradition of MacAdmins sessions, we are theming it around food. I know everybody thinks about the peanut butter and jelly documentation session, but really I think about Shay Craig and his Python taco session when I draw the analogy. So that's where this comes from. But to be clear, we're not really going to be talking about making chicken wings with Lambda functions because you can't really do that. Amazon does not have chicken wings as a service, especially not through Lambda functions. But we could use that for the theme of building an API together. So serverless development, and that's really why I'm umbrellaing Lambda functions under here. That's really something that has been taking off a lot in the last few years. It's the default for a lot of groups nowadays if they're trying to build something that's not going to be hosted on-prem somewhere. Obviously, on the other side of things, you still got containerized development, building applications that'll run in Docker, Kubernetes, or whatever other flavor of scheduler you happen to be using. But here, though, we're talking about serverless, and that means really leveraging managed services in AWS through their APIs to orchestrate together a small application or a large service that will do something for you. And in this case, we want to make something that will give us chicken wing recipes. This is not exactly what Eric Gomez asked for when I asked for ideas for sessions, but this is what we're getting. A part of that is really the Lambda function sort of sits in the middle. The code really is just handling the business logic. You still have how you're storing and retrieving data, which is not something I've talked about in any past sessions for MacAdmins. So that's what we're going to be doing a little bit of time talking around, because your function is only one part of the overall puzzle. So first, let's get into a little philosophy here. Let's talk about what makes a chicken wing. Chicken. Kind of hard to have a chicken wing without chicken, so clearly we have that. But we also have seasonings. Some chicken wing get dry rubs. You have different cooking methods for them. You have sauces that you toss them in. You have dips that you're going to go then dip those wings in, whether they're sauced or not. These are sort of the things that we think about when we are thinking what makes up a chicken wing. Well, then what kinds of chicken wings are we dealing with here? Well, we have traditional wings. These are going to be bone in. Generally, they're not battered. Don't at me, but they're not battered. And you got a variety of ways of making them. Fried is the one that really comes to mind, but baked chicken wings are a thing. Smoked chicken wings are a thing. So we have a few different ways of preparing them. And then we've got the other side of the spectrum where we've got the boneless wing. And the boneless wing is kind of a glorified adult chicken nugget. They are battered. Like, these are always battered. If it's not battered, it's not really a boneless wing. They're still tossed in sauce and they still have dips, but they also don't get smoked at all, really. Like, the recipes always call for frying or, in some rare cases, baking them. I don't really know how that works out, but I would generally always fry a boneless wing. So we've got these two types here, and we're thinking, okay, well, we've got these different cooking methods. We know that we can smoke them, we can fry them, we can bake them, depending. We know that we're going to have ingredients. We know that we're going to be cooking them at a certain temperature depending upon the method, and there's a certain amount of time with that. We have instructions and steps that we have to follow. So that ties into our cooking methods here. Those are sorts of the key attributes of our cooking methods. Sauces and dips, though, they kind of fall into the same thing. A sauce, you're going to have some ingredients. You're going to mix all those ingredients together, and then you're going to toss your wings in them. And then for your dips, you're going to have ingredients that you mix together, and then you will later dip your chicken wings in. So these two are actually kind of the same thing. And this is all really strange for a session about Lambda functions that I then said was going to be about serverless, and I'm not talking about any of those things. But really, if you're sitting down and you're thinking, I'm going to design something, and it's going to talk to different cloud services that I use or different things that I have, different things that I want to tie together, and I got to build some business logic around it. One of the key things you have to do up front is really you have to identify the data that you need, and then you have to identify the way that you're going to be accessing that data. So right now, we know what kind of data that we have. We've got cooking methods, we've got sauces, and we've got dips. And the whole thing is built around chicken, so we're not going to consider chicken a data type, but we have all these things that happen to our chicken. So we have these data types. And if we're building an API, we have to think, well, what are we doing with these? Well, we need to add cooking methods, add sauces, and add dips. Well, we're not really reading those back from the API. From the API, we want to give it a whole bunch of methods, and then we want to be able to get something that combines them all together back again. So we have recipes, and we have a randomizer. So I have a very simple API scheme going on here. We have a components resource group, and then we have cooking methods, sauces, and dips, and we post to those. And then we have just a root level recipes resource, and we're going to get that. And that's going to give us back a randomized recipe from the various types of data that we've stored in the system. And just for a quick refresh for those who don't really work with HTTP-based services too much, the protocol uses methods to describe how we are interacting with it. So a post, a put, and a patch, those are all about writing data or modifying resources. The get is used for reading it back, and then there is the delete, which should delete a resource. We're not touching deletes, puts, or patches, though. We're just focusing on writing some data in, and then we're going to get something back out. So now we're going to come back into the things that sit on the other side of Lambda. So like I said, Lambda really sits in the middle. Your Lambda functions contain business logic. That's where your code goes that does the things that you need it to do. And in this case, we needed to be able to write some data somewhere that we can then go back and reference later. And my default, the default for my teams, and the default I try to really get other teams on board with is DynamoDB. So most of this group is probably familiar with relational databases like Postgres, MySQL. Especially if you're a Jamf customer, you're very familiar with MySQL. DynamoDB lives in a family of NoSQL databases like MongoDB. These are schemaless databases. Really, it's just like taking an item, a collection of attributes, and you're writing it in there, and it just takes whatever you write into it. That doesn't mean that your stuff doesn't have a schema or it doesn't have a structure or it isn't defined. It just means the table doesn't care what you put into it. And then those items are going to be indexed on certain key attributes, which we'll talk about in a little bit here. It is a serverless managed service. So that means there's nothing about setting it up that you care about. If you want to use DynamoDB, pretty much AWS has a control plane API for every one of the services. And if you want a table, you just tell it, I want a table. And here are the attributes for that table. And it creates the table. And then you can start using it over another HTTP API, which makes DynamoDB actually really, really great to work with because there's no special connector or session management or any of that stuff that you do, like if you were writing some scripting against a MySQL database. You just have an HTTP API that authenticates using IAM access credentials, and you can start reading and writing data according to the methods that they expose for you. Really great. All right, so stop me if you haven't heard this one before, but this application adopts a very minimalistic implementation of the single table design idea. So single table design really is about defining the keys for what you're storing in your table in a way that you're using generic attributes in order to actually store all this, but still have access patterns for a whole bunch of different types of things. I'm probably butchering that, and Rick Houlihan, I hope this never gets back to him and he hears that, but ultimately, we have one table, and we're only going to use one table. We're not going to use a table per type of item. Like in MySQL, you would actually have a database. And inside that database, you have multiple tables. And each table is a unique type of entity, and they might be associated to each other through foreign keys. In DynamoDB, when you create a table, really, you don't have to lock it in to just be like, this table is sort of this one thing. The way that DynamoDB works, you can make it so that you are able to store all sorts of things in that table as long as you have well-defined keys for enabling those access patterns without crossing the stream, so to speak. So one core tenet of that is that you have generic attributes. A table's primary key. So the primary key that identifies a unique item in that table is, it can be just a partition key, or it can be a combination of a partition key and a sort key. And in this case, in almost all cases for when you see people talking about single table design with DynamoDB, you always have a partition key and you always have a sort key. But they're not labeled in a way that identifies what they're being used for. They're just, like, in most cases, you'll see it just like this. It just says PK, SK, and there's really nothing identifiable about, like, well, what does this key attribute get used for? Where we get into that is how those keys are structured. So this right here is called an item collection. In your table, anything that has the same partition key value, so that PK column on the left there, everything that has the same partition key, and this only works if you're also using a sort key, I should clarify that, but everything that has the same partition key is grouped together logically. And in the back end, there's other stuff that's going on where they all end up on the same partition on the same storage node, but we're not going to get into that. But from a conceptual standpoint, as far as you're concerned, because of how we're interacting with the database, having everything grouped together under one partition key enables you to actually query for everything just on that partition key, and then you're able to drill down further. So if I was to say this C hash cooking partition key, if I was just to do a query against this table and say, give me everything where the PK equals C hash cooking, then I would actually get every single item in that partition in that query. So it's not just a matter of, hey, I'm storing a bunch of items. I have to know exactly what I use for every single key value. If I have logical groupings of items and they all belong together, I give them all the same partition key, and then I can query them that way. On the sort key, it's that combination of the partition key and the sort key that actually defines the unique item. So the rule is the primary key must be unique. If you have a partition key and a sort key, the combination of those two values must be unique. So that's why you can have items that have the same partition key, but they must have a different sort key value within that partition. So in this case, for a more specific query pattern, let's say that our sort key for cooking methods, we actually had at the beginning of it whether or not it was boneless or traditional. If I wanted to say, well, I only want all the cooking methods that are boneless or traditional, I want to be able to do that instead of just saying, give me all the cooking methods, I would say, okay, I will have at the beginning of my sort key the type, and then I'll follow it up with that unique identifier I created, because in this case, remember, partition key is non-unique, but the sort key is unique. So I have randomized identifiers for all the things I'm writing into this table. But if I wanted to group them further, not just on the partition key, I could say, okay, sort key is prefixed with the type. So now I can do partition key equals C hash cooking. And then the sort key begins with T for type hash, and then the type, like boneless. So that enables me to build into my index some granularity with how I go back to query it. And there are things that we're not touching on in this, like global secondary indexes, which then enable you to further expand this and generate more access patterns. But this is a very simple application, and we're really just storing 3 types of items. So when you go to store that data in DynamoDB, again, it's a schemaless database. That doesn't mean you can't design your items in a way that's going to benefit you as you're writing and querying data. So you kind of got 2 approaches here, or at least these are the 2 that I think about. There might be more. One is a flat structure. And that's where you saw that we had the PK, the SK, and the type attributes from that previous slide. Well, you could just, if it's a JSON value that we're writing to our API, all the keys in that JSON payload could just be attributes in the table. So the method, the temperature, time, ingredients, instructions, all that stuff, that could just be their own columns, essentially. The other approach is to actually nest the data about the item under one attribute. So in this case, I have an attribute called data. And then everything that I sent via my API to write into this item is nested under there. Now, there are pros and cons to both of these approaches. But the reason why I like doing the nested approach is because one of the other things that you can do when you're querying is you can tell DynamoDB, I want you to match based on these key values, but then these are the attributes I want you to return back. So I could do a query where I know what I want, and I give it, here's the partition key, here's the sort key, only give me back this data attribute. And that data attribute is pretty much a one-to-one mapping of the JSON that I took in, validated, and then wrote to the table. And it's a lot less work for me to prune out if I'm returning that data somewhere. In the flat structure, I need to be aware of my keys and remove them, which is kind of a waste of a lot of read operations. It's a lot of data you didn't need. Or I need to specifically spell out all the attributes I do want in order to avoid things like the keys or the type value or something. And then, well, that just doesn't scale too well, because let's say, oh, I just want to add some attributes to this item and allow more things to be written. Well, now I got to go back and update my code. If it's just under the data attribute, it simplifies things a little bit from an API standpoint. So that's a pattern I kind of like, and that's what we're going to stick with. So at this point, yeah, I keep talking about DynamoDB, and I'm not talking about Lambda functions. You're all wondering where this is all going. Well, hold that thought. You can stare at this picture of the dinner I had while making this presentation, because I had to fulfill this craving, staring at so many chicken wing pictures. And now we'll move on. And we'll get into the actual guts of our little serverless app, which, if you're in the PSU Mac channel on the MacAdmins Slack, I did post the links that you see in this presentation, so don't scramble. You can go there and copy a link. The code that I'm going through is in this repo. And this code deploys the service you see on the screen here. We're going to have an HTTP API that will invoke Lambda functions that contain our business logic for writing in components of a chicken wing recipe, as well as reading back a recipe generated from those components. And it has the DynamoDB table where we're storing all this stuff. So let's get cooking with Lambda here. And we're still not looking at code. We're going to talk about input validation, because if you're going to build a API in order to facilitate some workflow that you're doing, the most important thing you can do for yourself is actually validate the input, because whether you like it or not, once your API is out there, even if it's really a tightly controlled environment, it's beneficial if you make sure that even you can't screw something up if you're trying to write code against it. So JSON schemas. JSON schemas are hugely helpful. They're kind of verbose, but they actually will solve a lot of problems for you, and they make it easier to change your service over time and make sure that you're not breaking anything. So earlier we identified sauces and dips. They're kind of the same thing. We have ingredients and we have some instructions, and almost always it's going to be, here's a list of ingredients and go mix it in a bowl, but I digress. So this schema says, okay, we're expecting an object. So for Python developers, dictionary, and the additional properties false flag, that says that you can only supply what I define here. You cannot have other keys in here or properties that I don't account for. So right here in properties, we say name, ingredients, and instructions. Those are the properties that we expect in our JSON that's coming in. If we added another one like description and we tried to post, this input validation will fail, because it says, no, description's not accounted for, you're not allowed to do it. If you wanted to build something where you had strict requirements around certain properties, but then it's like, and you can pass whatever else you want, you just leave that off, or you set it to be explicitly true, and then it'll allow it. But at the same time, under that required, we are requiring all of these keys. So we don't have any optional properties. And then in there, we say name is a string, and there's no requirements on what it is. Ingredients are an array, and then it's an array of strings. So really think of it like sentences or steps. So, or individual line items for our ingredients. And those are both the same, but different key values so that it's distinguishable when we're going to build our client code that works against this. Now, cooking method, I thought I would show off something a little bit more complex of what you can do and where the benefits of getting into JSON schema really start to shine through. So it starts off much the same. We have the type object, additional properties, we're not allowing those. And we have, our requirements list, and we're kind of requiring everything. But then as we start getting down here, there's a whole lot more to this one. So we have, we have name, we also have type, we have a couple of Booleans for, is it battered, and does it even use a sauce? We'll come back to that one later. And then we have a temperature value, which is a number. And then we have our standard ingredients and instructions, but they have a minimum items requirement. You must pass at least one for this. And then under this olive block, we actually have some conditional things that happen based upon the values inside the JSON. So what happens here is if the type is traditional, we're going to enforce, okay, the cooking method has to be one of baked, fried, or smoked. And that's fine. That's where that enum is. We're saying it could be one of these values. And then for is battered, that must be false. But then on the flip side here, under the second one, we're saying if it's boneless, if the type is boneless, then you can only select baked or fried. Smoked is not an option. And then the is battered property must be true. So you can actually have a fairly robust schema that is actually fairly intelligent and knows that, okay, if a user sets certain properties, I have to go check on these other properties to make sure everything lines up. And then there's a whole bunch of more advanced stuff that even I haven't gotten into that about decomposing these things and making reusable blocks. And it's complicated, but for a lot of stuff, especially with Lambda functions that just handle one very specific type of payload, schemas generally stay nice and small and they're readable and they help you so much. Because if we wanted to expand our API, really using that previous storage pattern of where we just have a data map, I could come into the schema, add additional properties, add some conditions around those properties, and I don't have to change any code because all the code's going to do is validate that JSON and then write it all to the data attribute. This is actually something that's really saved me a bunch of times in some services I've written here at Jamf, because most of my implementations of features have just been going in and making a schema change. So if we have this JSON schema, how do we leverage it? Well, I'm going to show you two options here. The first is actually the JSON schema library, or package. So you can install that, make that part of the requirements file. You can see that in the repo. I'm actually embedding the schema file in here instead of as a separate JSON file. So it's just a Python dictionary. It's already in there. So when the Lambda handler gets invoked by our HTTP API, it's going to load that request body, and then it's going to use JSON schema to validate it against the schema that I have inside this function file. And if either it bombs out and trying to load the body of the request because it's not JSON or it's not there, or if the validation throws up on anything, we'll just send back a 400 bad request error to the client. Another way of approaching this is actually another package that's out there. It's called AWS Lambda Power Tools for Python. And Power Tools is pretty cool, and I'll touch on this in just a second here. But one of the things it's gotten here is it's got its own JSON validation function, and it's got this envelopes collection. The envelopes collection actually are mappings of where in select AWS event sources for Lambda is the thing that you're going to want to actually validate. So in this case, envelopes.api gateway HTTP, it actually paths out to where the body is expected to be, and then it will make sure that it loads that JSON for you. So you can see that I'm not doing like reading in the body and then having to convert it from JSON into a dictionary here. The envelope will take care of that for me. And then I'm still passing in the schema and I'm telling it what the event is so that the envelope can unwrap it. And then same thing, we can just return a 400 error if we throw an exception on the loading of it or the validation of it. And that's pretty cool. The thing about Lambda Power Tools, and they are something I'm trying to take more advantage of, is the fact that they're a suite of utilities. It's not just like the validation thing I showed you, but the validation thing has a lot of other cool stuff that you could take advantage of, because you can actually wrap your function in your code with something that says the input must match this schema and then the output must match this schema. So you can actually have an end-to-end validation that you are returning what you said you would return for your API, in addition to the client gave you what you said they have to give you for your API. But there's a whole bunch of other things in there too. Custom metrics, wrappers for SQS message processing, a lot of somewhat opinionated best practices just available as code. So if you install this and just use it, you're kind of getting a lot of breadth and experience from the AWS engineers and members of the serverless community that maintain this project. So if you are still kind of new to some of this, I might recommend you make this a part of your workflow and build it into what you're doing, because it removes a lot of boilerplate for you. So on the subject of that data in and out, well, now we need to write it, and then we have to return something to the client to let them know that we wrote it. wrote it. So hey, we finally have some more Python code here. In this case, I'm using Boto3 in order to communicate to the DynamoDB table. So when you are deploying a serverless application using SAM, which coming to that subject later, it takes care of generating the IAM roles that are attached to the function, and then making sure that the policies that you gave to that function are applied to that role. So that way, what's going on here is we're leveraging a lot of the auto magic that happens in the AWS environment. When I'm instantiating my DynamoDB table from Boto3 here, it's just going out into the runtime environment to fetch the temporary credentials that were generated for this function when it was executed, and then instantiating itself. Like, there's not a lot of code here, which is nice, but that's how that's working. And so then in our Lambda handler, after our JSON validation logic, I'm going to generate a unique identifier for this item, and then I'm going to include the request body with that ID, so that way, I have that whole body, as one dictionary, and then I'm going to actually put that under that data attribute, like you saw in the table design earlier. So we have the PK is going to be. Hey, I actually omitted something from my code here. So the PK is going to be C hash, and then the method, and then the component of our recipe, and then the SK will actually be an ID hash, and then that unique identifier that we just generated, and then we'll return back a 201 status code, 201 saying that we created the item, and then the JSON of that body that we wrote into the table. So if I deploy this and I go to try it out, we can see that, hey, it looks like it's working. So I've got a dip here. It's ranch. It's the ingredients to it are ranch, and I've got my instructions here to go to a store, buy ranch, throw it away because I should have made blue cheese dressing. But then on the bottom, we can see that I got the item back, so I know that it took all the data that I sent it. Plus, I have the identifier, and I have my 201 status code. This screenshot's from Postman, by the way. So if you don't use Postman, you should use Postman. It makes testing out your services a lot easier. So the other side of the story was, okay, well, yeah, if I gave it everything, it worked. What happens if I omitted something that I required? Well, here we dropped the ingredients and it said, hey, bad request. Okay, so that's good. I should go read the docs again because we document our stuff. And then I should make sure that, did I actually send this request? You can actually, from JSON schema, capture exactly what was missing and then format that nicely and then send that back to the client. We do that in a lot of our internal projects at Jamf. So there is an option. That code's not in the repo. I might add it later, though, if people are interested. So now that we've solved writing all this data into our API, we need to actually solve getting it back. So what we want is we want to generate a chicken wing recipe, and we want to have just stuff. We want to throw a whole bunch of components in there. It's like, I want a whole bunch of different cooking methods. I'm going to crawl the interwebs for them. I'm going to find dips. I'm going to find sauces. I'm going to compile all these recipes. I'm going to write all of them in there. And then I just want to keep pushing a button and getting back random recipes to try out. Well, as you saw from our table, DynamoDB has very clear ways of how you interact with data. You either have to know the full primary key, so the combination of the partition key and sort key, or you have to know at least the partition key and part of the sort key, or just use the partition key for that matter, and then you can get back lots of items. So what's going to be the most efficient way for this? Because when you're working with DynamoDB, you don't ever want to use something that's called a scan. And a scan is where you just crawl the entire table for everything that's in there, and then cherry pick what you want out of the results. The more data that goes in there, the more wasteful that becomes, and it just does not scale ever. That's why we have query, and that's why we have our partition key and sort key to enable us to have some access patterns. So I came up with two different ways of really doing this. And when I say came up with two different ways, I mean, I came up with one and then I stole another one off Stack Overflow. So the one that I came to was, okay, well, I could actually just get every single sort key for an item and just the sort key, randomly pick one of those sort keys and then go get that item. So the way this works is I'm going to query the table. I'm going to say the partition key equals my C hash component name. And then in the projection expression, I'm saying, just give me the SK. That's what the projection expression here in the code is. I'm telling it which attributes I want back. So I won't get back the PK. I won't get back the data map or the type attribute or any of that stuff. I'm just getting the sort key, because then I will use the random module to make a random selection out of all those sort keys. And then I will go and do a get item. So in this case, get item, I know exactly the partition key and sort key that I want, so I can get that one item and return the data from it. And in fact, you can see in my projection expression, I'm only asking for the data. There's some special syntax there because data is actually a reserved word in DynamoDB, so you have to give it a placeholder token in the syntax. But don't worry too much about that. We're going to hand wave that away right now. Now, this is okay. The other way to go about this actually is doing a randomized prefix and then doing greater than or less than. So again, that sort key, we can do different types of query patterns on it based upon how it starts. You can't do anything on how it ends, mind you, just with what's at the start. You have to go from left to right when you're building out your queries. So here I'm saying, okay, well, how about I build that 8-character prefix on my UUIDs. I'll build a randomized one, and then I've got this little inner function here to go grab a DynamoDB result. And really, it's the same thing as before, except you can see under the SK, for when I'm calling this, I'm passing it an SK, and I'm saying SK must be greater than this value. So ID hash and then that character prefix. So the UUID is, that really long multi-segment string that you saw before, but because it's a sort key and it's really doing an alphanumeric sort of the items in there. That might be inaccurate. Don't quote me, but they are sorting it based upon the value of that sort key. So if UUID starts with lowercase a, and then another one is a lowercase z, then it's going to be the a will show up first and then the z. And if it's really the whole alphabet, you can do less than G or greater than G, and then you can go in either direction up and down that index. So in this case, the idea is, okay, well, let's generate something random with enough randomness that we don't just lock ourselves to one item accidentally. And really, we could have just generated a whole UUID for this too. And then we'll say, we're going to make one attempt to grab something that's greater than this. Now, there's always the off chance, especially if you have a low data sample, that you don't have anything greater than what you randomly generated. So then if that doesn't return anything, we will do the reverse and we'll say, okay, now give us something less than or equal to that randomized prefix. So there are trade-offs in both approaches. With a low data set, grabbing the sort keys seem to produce better randomness. But you're also always making two queries. You're doing a query for all the sort keys, which the more items you have in that partition, the more data that is that you're kind of wasting as part of that pattern. And then you're turning around, you're doing a get item. The randomized ID query seems to be a lot more efficient because, hey, most of the time you should only be doing one query, and then you should be able to get that. And I'm going to back off for a second because there was one other thing that was in here, the limit one. I was saying that as part of this query, only give me one result from this. That was how, in the event that there wasn't anything greater than that, we would reverse it and they'd say, okay, well, now give me something that's less than or equal to. So there are trade-offs in both ways. It kind of depends on what you're storing, if you know whether or not there's going to be a lot of it and how much the randomness factor matters. And also the way that you're storing that sort key value, like it works, like maybe something else would work a lot better for that. One great thing to do with sort keys, especially, is timestamps, ISO timestamps, because those are always alphanumerical sorted, and it makes it for a really easy way to do greater than, less than, or between two values. Between is another great query pattern that you can do with the sort key. So in this case, I'm just going to stick with my random component by key, so that grabbing all the SK values and then randomly picking one, I'm just going to stick with that for this. So in our Lambda handler now, we're taking that earlier code, and now we're going to actually, you can see here that we've got some conditions on it. So this is where the business logic around our accessing of data comes in. I'm going to be able to build out a response, and we're always going to have a method, so we will always get that. But then we're going to introduce some conditions, and the conditions are in two places. One is in our cooking methods earlier, we had a Boolean flag for is sauce. That was what it is. Does this no sauce? true or false. So we could have wing recipes that don't use a sauce with them because what you're doing is the wing. Or maybe I want to generate a recipe and I want to say I don't want to have a sauce, just give me, cooking method and a dip. Or maybe I just want the cooking method, a sauce, but no dip. Or maybe I just want the cooking method, period, no matter what. So this is an API. So one of the knobs that we can use to our advantage here is query string parameters. So, when you enter in a URL, use a question mark, and then you have some values after that separated by ampersands. Those are query string parameters. And what we're going to do here is we're going to have a no sauce and no dip query string parameter whose just their presence will be a Boolean. If present, that means that we don't want to do this thing that we're defining. And then we're also going to account for inside our method the use sauce attribute. Is that true or false? And then we're going to take it all together, package it up, write it out to JSON, and then return that to the client. And so we're back in Postman here, and I know this is kind of small. Hopefully you've got this a little bit bigger on your slides, but up at the top there, I'm doing a get on /recipes, and hey, one of the first results I actually got back when I was testing this was one of the recipes where I said use sauce is false. I don't have any query string parameters up there, and it skipped giving me a sauce. So I've got this, which one is this? This says the salt and vinegar wings. So I've got the salt and vinegar wing cooking recipe, and then I've got the ranch there. It's still telling me to throw it away, but I've got the ranch there. But our condition did hold, and we did not get a sauce back. And then I rolled it again, and then hey, now we've got a restaurant style cooking method, which is just fried. And then we've got lemon pepper, which is just some olive oil and lemon pepper, and the wings will get tossed in that. And hey, there's our blue cheese dip recipe. Great. Now let's see if our parameters are taking hold. So I've now slapped on no sauce. I want a recipe with no sauce, and boom. We've got our instructions for it. This looks like boneless wings. This is boneless wings. So we got boneless wings and ranch dip, and we've got no sauce with them. That is a chicken nugget. Okay. All right, now I'm going to say no sauce, no dip. Just give me a way to cook my wings. And here we go. We've now got crispy baked chicken wings. So we got a baked chicken wing recipe, but we've omitted the sauce and the dip, and our parameters are working. Awesome. You were told there would be YAML. I think somewhere in the description of this presentation, I said there would be lots of YAML, and we haven't really seen any YAML. We've seen JSON, though. We've seen lots of JSON, but no hipster JSON. Well, yes, you were told there would be YAML. And while you stare at this picture of wings from D-Spot here in Minneapolis, well, actually Woodbury on the St. Paul side, but anyway, from where I live, let's now get into tying this all together. And let's do a quick template walkthrough, because we looked at a bunch of things. We know that there's an HTTP API, but we haven't really talked about that. And the thing is, when you're building things with AWS SAM, which is itself an extension of CloudFormation, you can actually do it in a way where you don't really get concerned with defining the API. The API is just an event source, and then it takes care of it for you. We're going to look at that in a minute here. So we went through our table. We went through the code in our Lambda function that had all of our business logic. So really what we need is we need a template to take all those things that we've talked about and make it so that we can deploy this service as many times as needed. Maybe we just need to be able to have it in multiple environments so that we can test in a dev environment and then have an exact copy of it in production after our test pass. Or maybe it's just something where we're sharing it via GitHub with the community, and if somebody needs to roll their own version of it, they can just clone the repo, run a SAM command, and then deploy their own stack. So let's get into the template here. At the very top, we're actually defining a few things here. So I keep saying SAM, and for those who aren't familiar, SAM is just abbreviated for Serverless Application Model, and it is a set of CloudFormation resources that simplify developing serverless applications. And it works, it's just pretty much native CloudFormation at this point. So we have our standard header for the AWS template version, and then under that we have a transform, which this string right here just tells CloudFormation we're using serverless resources as part of this. When you're building these, there's some things in there that allow you to remove a lot of boilerplate from the YAML definitions that you do later on. Globals is one of them. So really in globals, I'm saying for every single function in this template, They all are Python 3.8. Their handler is index.lambda handler. So index is actually the file name, so index.py. And then the inside function that will get invoked is called Lambda handler. I'm saying this is the same for every single Lambda function in this template. This is what you're going to use. And then every Lambda function will have the table, the DynamoDB table's name as an environment variable. This removes 1, 2, 3, 4, 5. It removes 5 lines of YAML from every single function that I defined in this template. And there's more options here that we're just not taking advantage of. So it's a way to remove a lot of repetitive boilerplate template from your application template. So now we're getting to the defining the resources, and here is our DynamoDB table. One quick note here. The billing mode I have on here is pay per request. So DynamoDB does have 2 different modes of running. One is this, where you pay 25 cents for every 1 million read operations, and then $1.25 for every million write operations. You might not even see this on your bill if you build a service that uses the pay per request billing mode, and it's just not heavily used because they aren't going to round you up to a penny. There is another mode where it's provisioned, and provisioning gets into read and write capacity units, and those have their own scaling things. The beauty about pay per request mode is if your service starts getting more traction, it just scales up for you. You don't have to do anything. It's super nice. But I will say that the provision capacity mode, the first 25 read and write capacity units for your account are free tier. So as long as you're not exceeding those, you could provision like 5 to this table for each, and it would definitely not show up on your bill at all. You just might, if a service started to scale out and you didn't turn on the auto scaling features for your capacity groups, you might get throttling. You have to be really using it though in order to start hitting those, or have really bad access patterns like scan operations. Be wary of those. But you can see here, there's our PK, there's our SK. We're saying that those are keys, those are key attributes. And then none of the other things about our items that we're storing are in there at all. Again, schema list. The only thing we have to do is tell DynamoDB which attributes are key attributes and which indexes do those key attributes get used in. We only have the main index here, so we only have to define the PK and the SK. They're both strings, and we're done. So here we actually have our first Lambda function, and it's the Lambda function that handles the write requests for our components. So we already walked through all the code for these. The code's going to be located in the source directory and then the components directory, and then there's going to be an index.py file there that has everything that we walked through. I'm also attaching a IAM policy. I'm saying this Lambda function has permissions to write to this table. So the table that we were just looking at, it's referenced down here. So it's putting the name in there. That'll assemble the IAM policy for us when we go to deploy, and the Lambda function will get permissions to be able to do write operations. Not read operations though, just write. And then below that, there's our events. Post cooking methods, post sauces, and post dips. They're all HTTP API type events. And then in their properties, they're all post methods, and then they each have their path defined. So this gets into some of the auto magic that Sam gives us. Because I've defined an HTTP API as the event source, even though I don't have the API resource defined, Sam will extrapolate that and then make sure that one is created that these functions can then have event sources attached to. So that way there's a routing between the path I've defined here and then invoking my code out in the cloud. So that's pretty cool. And you can see here, I actually went with the pattern of I have one function and it does the same thing. So I have both schema types in there. The sauce and dip schema and the cooking method schema are in the same function. And then I'm just checking to see what type of path was invoked in order to then say which schema am I checking against and what are my keys for the index for the DynamoDB table going to be. You can go check that out in the code. I don't think we covered that in this, and I skipped over it. But I have 3 different API paths on one function because they are all similar enough. It didn't warrant splitting it out. Now, for reading recipes, a little bit different. So in the source directory, there's a recipes directory, and there's an index.py file in there that contains our randomizer code that we looked at before. And here, I'm giving it another policy, which is just a read policy. This Lambda function can only read from the table. It can't write to the table. I have to explicitly give it that permission if I change my mind about this later on. Maybe I want to include an option where, hey, save the recipe I randomly generated. But here, there's only one event. It's just the get event. Type HTTP API again, get method, and /recipes. And really, to sort of tie all this together even more, instead of just watching a scrolling wall of YAML, we have a little deploy demo. So I tore down the stack that I was testing with while I was building this presentation, and I decided to redeploy it. So in here, this is PyCharm. On the left-hand side, you can see that directory structure I talked about. Root of the repo, there's my template file, exact template file that we just scrolled through. Then I have my source directory where my function code is. There's the components function, there's the recipes function, there's the requirements file. So like the recipe function doesn't have any requirements, but the components function has JSON schema defined. So that way, when I go to do this, it's actually going to install those packages and bundle them with the code before it uploads it. So we got a little video here. What I'm going to do is I'm going to use the SAM command in order to do a build. And with container just means use Docker to run the build in a container that mimics the Lambda environment. So that way I get an end result that's built using something that's as close to where it's going to be running. And that was pretty quick. So it's built both my functions, and so cached those locally. And now I told it SAM deploy. And I didn't pass anything else in there because there's a SAM config tumble file highlighted on the left there that actually I saved all the options for, like, where am I deploying this? What bucket does it upload to? What AWS profile am I using for doing all these actions? But like now it's actually going through, and we can see CloudFormation is generating a whole bunch of stuff I didn't even have defined. And that's where those serverless resources come in. The serverless resources are really a bunch of things all bundled and wrapped together in one little definition, and then they get extrapolated out into all the base CloudFormation components by the transform. And now that it's done, I actually included some outputs in this so I can see the name of my table. And then if I need to do any like local testing and I want to go out and actually mess around with it. And I also have the API for me to go interact with it. That might or might not still be up and running. I don't remember actually. So do be gentle, at least until I tear it down. But now I can actually go out and I can start using the service. And that's what I did to pre-populate with the data to generate the examples that we saw in this presentation. All in all, pretty slick. If I wanted to actually make any changes at this point, because I used that cached command on SAM build, I could go into one function, make a bunch of changes. And then when I run SAM build, it's only going to rebuild the one that I changed and then just update the stack. And now I have a really nice, fast development iterative cycle. Where we're going to leave off on here is, if you would like to know more, I'm actually not going to point at anything of mine for this. I'm going to point at this guy. This guy is Eric Johnson. He is a principal developer advocate for serverless at AWS. And he does a series called Sessions with Sam, where he actually walks through a whole bunch of stuff, just all the way from introduction to some of the really more advanced stuff that you can do with serverless development using SAM. You've also probably heard of things like CDK, Terraform, the actual serverless framework. AJ would be mad if I didn't actually mention that. So there we go. AJ, don't get mad at me. So there's a whole bunch of stuff there. It's not just the videos, though. Like it's not just sessions with Sam. You can find ready-to-use template snippet design patterns for basic serverless patterns. So event source, the Lambda function, or service-to-service event linking, like all sorts of great stuff. And a lot of stuff that you can just lift and shift, copy and paste, and then adapt for something that you're building. So I'm going to say thank you here. There might be time for Q&A. I don't know how long I went exactly, but even if there's not time, I'll see you in Slack.
All right.
I don't know how to stop sharing my screen.
Thank you so much, Bryson, for that detailed and very informative presentation. We do have one Q&A question, and it's from Elliot Jordan, who asks, if the combination partition key and the sort key is already unique, e.g. cooking #traditional, then why is the additional identifier string suffix used in the sort key?
So in that case, the design pattern that I was demonstrating was actually doing a further grouping beyond just the partition key. So all those items are in one collection because the partition key is all the same. But if it was just the identifier afterwards, which is actually how I ended up implementing this application, mind you, then that randomized identifier for each and every item is what makes that primary key unique. The prefixing with, say, type traditional means that if I wanted to be able to segment out the item collection even further, so I could be like, oh, I just want to query for all cooking methods that are just traditional, then I have to actually bake that into the pattern for my sort key. So by prefixing it like that, the prefix is a static value that I'm now able to use in my query. So the idea there was, instead of just querying for all cooking methods, getting them all, and then sorting through them in the code, if I had something that I could then subpartition on, like the type value, I could make that a prefix, and then my query pattern becomes pk equals cooking method, sk begins with traditional, and then I would get every single cooking method that was meant for a traditional type. I didn't do that in the code that's out of the repo, though. I kept that in the slides as an example of how to build out query patterns. Because the thing with DynamoDB is you have to make a lot of these decisions up front. You have to know what you're storing and how you're accessing it, which informs how you structure the values that go into those keys to enable the query patterns that you use later on. Now, if you had to change your mind about something later on because you didn't account for something up front, or you decide that, well, we don't need this access pattern anymore, I need to make a change, that turns into a little bit of a migration, because you might want to actually move those items. You might want to copy them and then delete the old ones after you've written them in with the new keys that you defined. So, Elliot, hope that answers that one.
Great, thank you so much. That actually will do it for our Q&A. I would like to thank Bryson very much for taking the time to deliver today's second session. And with that, it actually wraps up today's Campfire Sessions.